What if the AI boom we're living through right now is just the opening act for a transformation so profound it will fundamentally reshape reality as we know it? Because that is precisely what is happening, behind closed doors, in the strategic heart of Nvidia. The king of AI is secretly building the engine for the next universe of computation, a world where artificial intelligence merges with the almost mystical power of quantum mechanics. This isn't just a story about a new chip or a faster computer. This is a story about the dawn of a new technological epoch, a calculated masterstroke to build and control the very foundation of our future. Today, we pull back the curtain on one of the most audacious corporate gambles in history. This is the story of Nvidia's secret quantum leap. To understand the sheer scale of this ambition, we have to look to the visionary conductor of this orchestra, Nvidia's CEO, Jensen Huang. At the recent GTC 2025, a conference typically dedicated to the graphics and AI technologies we already know, Huang painted a picture of the future that left the industry reeling. He described a world not where quantum computers replace our current supercomputers, but where they work in a seamless, powerful tandem. Imagine for a moment the most complex challenges humanity faces. Curing Alzheimer's or cancer isn't just about finding one magic bullet. It's about understanding a near-infinite web of protein-folding combinations. A puzzle so complex that all the computers on Earth working for 1 billion years couldn't solve it. Think about climate change. It's not just about reducing emissions. It's about discovering new catalyst materials that can scrub carbon from the atmosphere efficiently, or engineering revolutionary battery technologies that can power our world cleanly. These problems are what we call computationally unsolvable. They have more possible variables than there are atoms in the known universe. This is where Jensen Huang's vision ignites. He sees Nvidia's powerful AI supercomputers, the ones that are already changing our world, as the tireless, brilliant workhorses. They can sift through mountains of data, recognize patterns, and manage immense, complex systems. But for those truly impossible problems, those moments that require a leap into a realm of infinite possibilities, they will hand the baton to a quantum processor. The quantum computer, in this vision, is the virtuoso soloist, the savant capable of exploring every possible solution to a problem simultaneously. The AI is the orchestra, and the quantum processor is the transcendent soloist. Together, they can play a symphony of creation that neither could ever perform alone. This isn't a strategy to simply build a better chip. That's thinking in the old paradigm. This is a calculated, multi-decade strategy to build and own the entire concert hall, to write the sheet music, and to be the indispensable conductor for the next generation of computing. It's about creating the very fabric upon which the solutions to humanity's greatest challenges will be woven. But a vision, no matter how grand, is just a dream without a practical way to build it. And this is where we find the technical heart of Nvidia's strategy, a masterwork of engineering called CUDA-Q. To truly grasp its importance, we need to understand the fundamental barrier it breaks down. Think of classical computing, the world of GPUs and CPUs, as a world of light switches. Everything is a 1 or a 0, on or off. It's incredibly powerful, and by flipping billions of these switches billions of times a second, we've built our modern world. Now think of quantum computing as a world of dimmer switches. A quantum bit, or qubit, isn't just on or off. It can be on, off, or a delicate, probabilistic blend of both at the same time, a state we call superposition. And through another spooky property called entanglement, qubits can be linked, their fates intertwined no matter the distance. This allows a quantum computer to explore a vast landscape of possibilities all at once. The problem? These two worlds speak completely different languages. A GPU architect and a quantum physicist might as well be from different planets. Writing code for one is entirely different from writing code for the other. This has been the Great Wall separating these two powerful domains. CUDA-Q is the universal translator. It is the Rosetta Stone that allows these two worlds to not just talk to each other, but to think and work together. Announced in its latest, most powerful iteration in August 2025, CUDA-Q is an entire ecosystem. It allows a developer who might be an expert in AI, but a novice in quantum mechanics, to write code that seamlessly offloads the parts of a problem that are classically impossible to a quantum processor, while keeping the rest of the workload on the screaming fast GPUs. It's like being a film director. You have your main crew, your classical GPUs, shooting the majority of the scenes. But for that one impossible, mind-bending visual effect, you don't have to fire your crew and hire a new one that speaks a different language. With CUDA-Q, you can simply send that one shot over to a specialized quantum VFX team, and their work integrates perfectly back into your final film. This creates a vital, harmonious link. It allows the brute force power of AI to set the stage, and the subtle, probabilistic power of quantum to solve the unsolvable riddle at the heart of the play. It's the bridge between worlds, and Nvidia is the only one who has built it at this scale. A revolutionary platform is one thing, but a global standard is another. Nvidia's strategy extends far beyond its own labs. Their goal is to make CUDA-Q the indispensable operating system for the entire quantum era. And their recent moves show they are playing a game of global chess. In May 2025, a landmark partnership was announced. Nvidia would be powering Japan's ABCIQ system, a monumental project designed to be the world's largest and most powerful quantum research supercomputer. Now, this wasn't just a simple sales deal, shipping boxes of hardware. This was a deep, intricate collaboration to build the blueprint for the future of scientific discovery. The ABCIQ system isn't just a classical supercomputer with a quantum computer bolted on the side. It is a truly hybrid system, designed from the ground up for this new paradigm. Imagine a biologist using this system to design a new drug. The AI component, running on thousands of Nvidia GPUs, could first scan a library of billions of chemical compounds, using its pattern recognition prowess to identify a few thousand promising candidates. This is a task classical computers excel at. But then comes the hard part: simulating exactly how each of those candidate molecules will interact with a target protein in the human body. This is a quantum problem. With the ABCIQ system, the researcher doesn't need to switch machines or rewrite their code. The system, guided by CUDA-Q, will automatically execute those complex simulations on its integrated quantum processors, feeding the results back to the AI. The AI can then learn from these quantum-accurate results, refine its search, and propose even better candidates. This is a live, real-time conversation between the two forms of computing. By powering flagship national projects like Japan's, Nvidia isn't just selling hardware. They are embedding their software, their architecture, their very philosophy into the foundations of global quantum research. They are teaching the world's brightest minds to speak their language, ensuring that as quantum computing matures, it matures on an Nvidia-powered platform. This leads us to one of the most brilliant aspects of Nvidia's strategy. They are not actually trying to build the world's best quantum computer. This might sound counterintuitive, but it's a move of pure strategic genius. While giants like Google, IBM, and a host of startups are locked in a fantastically expensive and difficult race to build more and more stable qubits, the core processing units of a quantum computer, Nvidia is taking a different path. They are positioning themselves to be the indispensable partner to all of them. Think back to the dawn of the personal computer. There were dozens of companies building PCs: IBM, Compaq, Dell, Gateway. But what did they all have in common? For decades, the vast majority of them had a sticker on the front that said Intel inside. Intel didn't care who won the PC wars because they were supplying the crucial component, the microprocessor, to everyone. Nvidia is executing the 21st century version of this playbook for the quantum era. Their message to the world, explicitly stated at conferences like Supercomputing 2024, is this: you build the quantum processor, whether it's based on superconductors, trapped ions, or photonics, and we will provide the engine to make it sing. By creating the essential software and acceleration stacks with CUDA-Q, and by forging deep partnerships with a diverse range of quantum hardware companies like Quantum Circuits Inc. and system builders like Supermicro, Nvidia is weaving a web. They are fostering a comprehensive ecosystem where they are the central, critical hub. They are ensuring that no matter which company ultimately builds the most powerful quantum processor, that processor will be exponentially more powerful and useful when it's connected to Nvidia's GPUs and running on Nvidia's software. They are betting not on a single horse, but on the entire racetrack. To truly appreciate this hybrid strategy, we have to confront the single biggest monster that stands in the way of practical quantum computing: errors. Quantum states are unbelievably fragile. The slightest vibration, a stray magnetic field, or a tiny temperature fluctuation can corrupt the delicate quantum calculation, a phenomenon engineers call noise. It's like trying to perform microscopic surgery during an earthquake. This decoherence, as it's called, is the Achilles heel of the quantum dream. A quantum computer that makes constant errors is nothing more than a very expensive random number generator. This is where Nvidia's strategy becomes so elegant. They are tackling this fundamental quantum weakness with their own unique classical strength. They are using the raw, unadulterated speed of their GPUs to run incredibly sophisticated, real-time error correction algorithms. Picture the quantum processor as a brilliant but temperamental artist trying to paint a masterpiece. The noise is a constant tremor in their hand, causing stray brushstrokes that could ruin the painting. Now, imagine an Nvidia GPU as a hyper-aware assistant standing right next to the artist. This assistant is watching every single motion, and using its lightning-fast processing power, it can predict when a tremor is about to happen. Before the stray brushstroke can even touch the canvas, the assistant subtly adjusts the artist's hand, canceling out the tremor. It does this thousands of times a second, so fast that the artist's creative flow is never interrupted. The final masterpiece is perfect, not because the artist was perfectly steady, but because they had a guardian angel correcting every potential flaw in real time. This innovative hybrid approach, using classical power to stabilize quantum delicacy, creates a far more robust and reliable system. It's a crucial, practical step that turns quantum computing from a fascinating laboratory experiment into a viable, powerful computational tool. Nvidia is not just connecting the two worlds. They are using one to solve the other's greatest weakness. The relationship gets even deeper. It's not just about GPUs helping quantum processors. In a beautiful, virtuous cycle, Nvidia is also using its world-leading artificial intelligence to make quantum computing better, faster, and more efficient. This is where the synergy becomes truly exponential. Designing a quantum algorithm, or a quantum circuit, is an incredibly complex task. It's about arranging a sequence of quantum logic gates to solve a problem. Finding the optimal arrangement can be a puzzle with more possible solutions than atoms in the universe. An inefficient circuit can require more qubits or take longer to run, making it more susceptible to those dreaded errors. Here, Nvidia unleashes its machine learning algorithms. Their AI can analyze a proposed quantum circuit and automatically optimize it. It can look at the problem and say, you can achieve the same result with 20% fewer gates, and in half the time if you arrange it this way. It learns from millions of simulations, developing an intuition for quantum algorithm design that surpasses even human experts. The AI becomes a quantum architect, improving performance and dramatically reducing error rates. This creates an incredible feedback loop. Better AI running on GPUs leads to more efficient quantum circuits. More efficient quantum circuits allow quantum processors to solve more complex problems. The solutions from these quantum processors can then be used to train even more powerful AI models. Each advancement in one domain directly accelerates the other. It's like two climbers scaling a sheer cliff face. By working together, they ascend at a speed that would be impossible for either one alone. This synergy is what has led to the staggering performance gains we're now seeing. The results of this hybrid strategy are nothing short of jaw-dropping. By combining GPU-powered simulation, AI-driven optimization, and real-time error correction, Nvidia's quantum simulation capabilities have seen a 1,000-fold improvement in just the last 2 years. Let me repeat that, a 1,000 times increase in performance, and they are projecting another 100-fold increase by 2026. This is a pace of progress that defies Moore's law and exists on a completely new exponential curve. This rapid, almost violent acceleration has forced a profound shift in the perspective of the man at the top. Jensen Huang, once a noted public skeptic about the near-term viability of quantum computing, has completely revised his outlook. He now openly suggests that quantum computing is rapidly approaching an inflection point, a moment of critical mass where its practical impact will become undeniable. When a leader who built their empire on pragmatic, real-world results begins to speak of an inflection point for a technology as futuristic as quantum, the world takes notice. And take notice it has. The market, once viewing Nvidia solely as an AI company, has woken up to this second, even larger act. The company's stock surged over 200% in 2025 as savvy investors began to understand that quantum computing is not a side project for Nvidia. It is the company's next great growth frontier. This quantum leap has sent shockwaves through the tech landscape, forcing competitors into a frantic race to recalibrate. Microsoft, a major player in both cloud and quantum, is dramatically increasing its investment in its own hybrid systems. Amazon's Bracket cloud service, which provides access to various quantum computers, has now prominently integrated Nvidia GPU acceleration to help its customers. Even the notoriously secretive Apple is discreetly but aggressively expanding its quantum software engineering teams. The race has changed. It's no longer just about building a quantum computer. It's about mastering the hybrid quantum classical world that Nvidia is pioneering. This all might still sound like science fiction, a battle of titans in a far-off technological realm. But the reality is that Nvidia's quantum-enhanced AI systems are already delivering tangible, concrete value to businesses today. Take the world of finance. A major investment bank is using quantum-inspired algorithms running on Nvidia GPUs to solve incredibly complex portfolio optimization problems. They need to balance risk and reward across thousands of assets, with millions of interdependent variables. A classical computer might find a good answer. A quantum-inspired system can explore a much larger solution space to find a better answer, potentially adding billions in returns. In the pharmaceutical industry, companies are using Nvidia's quantum simulation platforms to accelerate drug discovery. Simulating the behavior of a complex molecule is a task tailor-made for quantum mechanics. By running these simulations on GPU-accelerated systems, they can understand a drug's effectiveness and potential side effects years earlier than was previously possible, potentially saving millions of lives and billions of dollars in research costs. This is the key. You don't need a massive, fault-tolerant quantum computer to gain a quantum advantage. By using classical systems that are powerful enough to simulate quantum mechanics, companies are already reaping the benefits. They are learning how to frame problems for quantum computers, building the algorithms, and seeing real-world results. Nvidia has, in effect, built a quantum flight simulator, allowing businesses to train for the quantum future before the planes have even fully arrived at the airport. This brings us back to that monumental number. $50 billion. This investment is Nvidia's grand wager, a bet on the very nature of the future. The company is wagering that the future of computation isn't purely quantum, nor is it purely classical. The future is a seamless, collaborative, hybrid paradigm. In this future, GPUs will remain the dominant engine of computation. They will handle the vast majority of tasks, the AI training, the data processing, the graphics rendering. But for a small, specific, yet critically important class of problems, they will call upon their quantum partners. It is a bet that the software layer, the bridge that connects these two worlds, is the most valuable and strategic place to be. Nvidia is betting that by controlling this indispensable hybrid software layer, they will control the future of computing itself. Success would position Nvidia to dominate the next era of technology in the same way Microsoft dominated the PC software era and Google dominated the internet search era. They would be the essential, high-margin, irreplaceable component at the heart of every major technological breakthrough for the next 50 years. This is the prize they are aiming for. It's a gamble of staggering proportions, but one built on a foundation of brilliant strategy and relentless execution. Looking ahead, Nvidia's roadmap gives us a tantalizing glimpse of what's to come. By 2026, we can expect a new generation of GPUs specifically engineered from the silicon up for quantum classical hybrid computing. We can anticipate major strategic partnerships with all the major cloud providers to offer quantum-enhanced AI as a simple, on-demand service. And we will see the rollout of the first enterprise applications that demonstrate a clear, undeniable quantum advantage for specific high-value use cases. The timeline for practical, impactful quantum AI is no longer a vague dream set in the 2040s. Thanks to this hybrid approach, many experts now project that timeline to be as early as 2027 or 2028. We are standing on the precipice of that inflection point. So what is the lesson for us in all of this? This story is more than just a tech saga. It's a masterclass in vision and strategy. It teaches us that the most revolutionary breakthroughs often come not from replacing the old with the new, but from finding an ingenious way to make them work together. It shows that true innovation often lies in building the bridges, the platforms, and the ecosystems that empower others. While everyone else was racing to build a faster horse, Nvidia was building the entire railroad. In our own lives, in our careers, in our problem solving, perhaps we can take a page from this playbook. Where can we build a bridge between two disparate ideas? How can we use our existing strengths to overcome a new and difficult challenge? How can we, instead of competing head-on, build a platform that everyone else needs to use? The future, it seems, belongs to the collaborators, the integrators, and the visionaries who see the symphony, not just the individual instruments. I'm incredibly curious to hear your thoughts. Do you think Nvidia's hybrid strategy is the right bet? Or will a pure-play quantum company eventually leapfrog them? What industry do you think will be the very first to be completely transformed by this new era of quantum-enhanced AI? Let me know your predictions in the comments below. Thank you for joining me on this journey into the future. I hope you found it as fascinating as I did. I wish you all the very best of health and clarity of mind. If you enjoyed this deep dive and want more content that decodes the future of technology and its impact on our world, please consider subscribing to the channel. It truly helps us continue to create content like this for you. Until next time.